11.8 shows you some practical ways that probability is used. And I like to teach it sooner than later because these problems take a little bit of a process. And I've learned that if my students see it a little earlier, they just need a little bit of time to practice these problems before they get to the test. I used to teach it in order and at the end of the chapter, and then students will only have like a couple days to really practice the problems before they had to test on it. And so I found that, you know, when you guys have a little bit more time to practice it, they seem a little complicated at first, but you'll see that there's a pattern to these problems. And you just need time to practice that pattern, and then it becomes a little bit easier to follow. All right, so expected value. Let's see what that means. Okay, so expected value is a mathematical way to use probabilities to determine what to expect in various situations over the long run. And you're going to see some examples of where people might use this in the business world and so on. Oh, sorry. Okay, everybody get those fill in the blanks? Okay, for example, we can use expected value to find the outcome of the roll of a fair die. Now, this is actually not the most practical use of expected value, but I show you this example because the numbers are small and easy, and it's easy to follow, what you're doing with the process. But the outcomes are 1, 2, 3, 4, 5, and 6, right? When you roll a die, you could get a 1, 2, 3, 4, 5, or 6. And each of them have a probability of 1/6. So the probability of rolling a 3 is 1 out of 6. Probability of rolling a 5 is 1 over 6. So the expected value, which we're going to capitalize as letter E, is computed by multiplying each outcome by its probability and then adding these products. So that is actually, that's how you find expected value right there, that second sentence. Multiplying each outcome by its probability and then adding these products. Now, I have organized the information in chart because I feel if you just learn the format of the chart, it helps you to organize your numbers and what you're supposed to do with them. So the first thing I've done is I've drawn this chart. The first column is outcome, and then the second column is the probability of each of those outcomes. Now, in most of the problems that you're going to do in the homework, the outcomes are not going to have the same probability. It just worked out that way because of the fact that we're rolling a die. All right, so look back at that last sentence. It says the expected value is computed by multiplying each outcome by its probability and then adding these products together. So here is where I'll actually make a third column for products, because what I'm going to do is I'm going to multiply each of these numbers in each row, and I'm going to write my answer in the third column. So the PowerPoint's actually going to demonstrate this for you. Okay, so we're multiplying each of these rows together. So 1 times 1, 6, 2 times 1, 6, 3 times 1, 6, and so on. And it's actually best to keep them in the form of a fraction because you're then going to be adding these. And it's actually better if you don't reduce because you want a common denominator when you're adding. So when we multiply it all together, here's what it equals. We get 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. So now the very last thing to do is to take this third column and add all these numbers together. So to write a total at the bottom of that column. Okay, so when you total it all up, you get 21 over 6. And now at this point, you want to convert this to a decimal. So the expected value is 3.5. Now, the one flaw that I see in this chapter is that they call expected value capital E. And we had already defined capital E in 11.4 as the experiment. The probability of E is what we talked about before. So these two E's are not the same thing. I wish they'd called it EV or something for expected value, but that's what it is. Now, this is what it means, is that over the long run, you will have on average a 3.5 when you roll the die over and over and over and over and over again. Okay, so again, it ended up somewhere in the middle because all these outcomes have the same exact probability. If they didn't have the same exact probability, you wouldn't get somewhere in the middle. Now, let's see a little bit more practical way of using expected value. One way to bet in roulette is to place $1 on a single number. Okay, so down in the bottom is what roulette looks like if you're not familiar. You, the person in charge spins the wheel, they roll a little white ball around, and wherever it lands, you don't know, you have to wait for the outcome. Okay? So if the ball lands on the number that you bet on, you are awarded $35, and you get to keep the dollar that you paid to play the game. If the ball lands on any one of the other 37 slots, you are awarded nothing, and the dollar you bet is collected. Okay, now, not every roulette table lets you bet $1. Most of them actually, you have to bet a lot more money than that, so just keep that in mind. But we're using $1 to make it a little more simple here. Okay, so to find the expected value here, we want to know what will happen over the long run, but this time we're more concerned about our money. Okay, how much are we expected to win or how much are we expected to lose when we bet on a roulette game? So, okay, so here's the question. Find the expected value for playing roulette if you bet $1 on the number 20. Let's say 20 is your favorite number. And so you bet $1 every single time on 20, hoping that it's going to hit. And then you're going to describe what this means. So the first thing you need to do is make that chart. Outcome, and I'm going to add one more column to it. So we're going to have outcome, gain or loss, and probability. And then there's also, you can also make your fourth column for products, if you wish, on there. All right, so you bet $1 on the number 20. What could possibly happen? Okay, I heard you could win or you could lose. Right, so there are two outcomes in this. It can either land on 20 or not land on 20. Okay, so land on 20 or you win. Not land on 20 and you lose. Okay, so if you win, what is your gain or loss? Say that again? No, $35. Okay, this is where it's helpful to have the handout. Okay, so the handout reminds you of what was in the problem there. You guys that have the handout have the information. So you win $35. Now it says that you get your dollar back, but that's not a gain. Okay, so you get your dollar. That's what you started with. When you get your dollar back, you break even. Okay, so you gain $35. So we're going to list that as a positive number because it's a gain. Now what happens if it doesn't land on 20? You lose $1. Now since this is a loss, we're going to note that as a negative number. So negative $1. Okay, what is the probability of landing on 20? One out of 38 is correct. Good. You had to read the problem carefully because it says it could either land on 20 or any of the other 37 slots. So how many total possible outcomes are there? 38. So there's only 120 on there out of 38. So what's the probability that you don't land on 20? 37 out of 38, right, because there are 37 slots that are not the number 20 out of a total of 38 possible outcomes. Okay, so we filled in our chart, and now we're really just concerned about our money. What's going to happen with, how much would we win over the long run, or how much will we lose over the long run if we continue with this particular strategy? So I actually don't need this outcome column anymore. I am now going to multiply the gain or loss with the probability. So multiplying across. So, and you know what, I'm just going to leave it in the form of a fraction because I'm going to be adding these numbers anyway. It'll give me a common denominator. So 35 times 1 over 38 is 35 over 38. And then negative 1 times this fraction just gives you the fraction negative. So negative 37 over 38. Okay, add these two numbers together. They already have a common denominator of 38. And so 35 and a negative 37 is negative 2. At this point, this is where you change that number to a decimal. Okay, everybody follow so far on what's in the chart. It's going to disappear for just a moment because I also have it typed in here, so just give me 1 second. Okay, so this is essentially what we did. I just didn't show it in the fourth column. Is 35 times 1 over 38 and negative 1 times 37 over 38, which gives us negative 2 over 38, which is the same as negative 0.05. Now remember that this was money that we were multiplying by, so it's negative 5 cents. So this is what this means. Over the long run, you cannot predict what will happen in the short run. But over the long run, if you always do the same thing, you bet on 20, 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 you're going to lose, 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 maybe win once. Then lose, 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 maybe win again, okay? And over the long run, you will lose about 5 cents per every game played. So roulette is not a winning game. It's a lucky game. It's not, it's not something that is known for something you win at all the time. But it all depends on whether this is worth the risk, okay? Maybe you just really enjoy it and you can afford to lose about 5 cents a game every so often. It's just like going to the movies. Okay, you go to the movies, you spend, what, 20 bucks after you pay for your ticket and, and a drink. And you don't get that 20 bucks back, right? But you're going to the movie to enjoy the movie because it's what you like to do. So you already know ahead of time that, yes, you can afford to spend that 20 bucks on there. So again, this is just, something that, you could, that someone might use to figure out, well, is this something worth the risk for me to do in the long run? Now again, remember that most places will not let you just bet $1 on roulette. You have to bet a lot more money, which means you will lose a lot more money per game in reality. Okay? Okay, short assignment for 11-8. All right, so here's another more practical way to use expected value. The table shows claims and their probabilities for an insurance company. Use the table to answer parts A through C. So it has already created a table for you. The first column is the amount of the claim. So somebody buys, let's say this is homeowners insurance. Somebody buys homeowners insurance, and a lot of times a claim on a house, for your insurance would be small. You had some small damage from a storm, or, something, small happened to your house. And the probability that you would have a claim that's close to $0. That doesn't mean that it's always $0. Notice that at the top it says it's rounded to the nearest 50,000. So this could be anywhere from, less than 25,000 down to 0. But the probability that you have a small claim is 0.65. So it's actually a high probability that you will just only have a small claim. The probability that you have a claim close to 50,000 is 0.24. The probability of your claim of 100,000 is 0.07. A claim of 150,000 is 0.02. Notice how much smaller the probabilities are getting. And then the probability of a claim of 200,000 is 0.01, and same for 250,000. So it's like a 1% chance that you're going to need to have a huge claim from this insurance company. All right, so to find the expected value, what do we need to do? Well, before you add, multiply. Okay, so we need to multiply each outcome with its probability, which if you wish, you can create a third column here for your products. All right, so you're going to multiply and place your answer in the third column. Okay, the first row, what's 0 times 0.65? 0, good. Okay, 50,000 times 0.24. 12,000. 100,000 times 0.07. 7,000. 150,000 times 0.02. 3,000. 200,000 times 0.01. 2,000. And 250,000 times 0.01. 2,500. Okay, any questions on those products? So now what do I do with these numbers? Add them together. Okay, so add up all of these. 26,500. And this is your expected value. Okay, multiply and add. That's your answer. Okay, so 26,500. Fantastic. Okay, now you need to understand what that means. Okay, so if you're ever asked to describe what expected value means, you should always start with the words over the long run or something similar to that. Okay, so over the long run, what would happen? Let's say you're the insurance company, and this is what the expected value is on your clients. Okay, so over the long run, each of your clients is going to cost you $26,500. Now, some clients will cost you nothing. Some clients they will never make a claim on their insurance. But then you'll have other clients that cost you a lot, and you have to pay out a whole $250,000. But over the long run, it's going to cost you about $26,500 to make sure that you can take care of all of your clients. Okay? So, if this is the case, how much should the company charge as an average premium so that it breaks even on its claim costs? The same amount as A is correct. Good. Because if this is about how much it's going to cost you per client over the long run, then if you take in that amount from each of your clients, then you'll make sure that you have everything covered. You'll break even. Okay, that's what breaking even means, is that you don't have any, you're not under what you owe, but you also are not making any money on that. So breaking even is $26,500. Well done. Okay, so, and again, this does not mean that they're going to collect $26,500 today from their client. Okay, they're going to break that up over payments from them. But the payments are based on how much they want to make sure they earn over a certain period of time. All right, so how much should the company charge if they want to make a profit of $50 per policy? Very good, $26,550. All you have to do is add what the profit is to what your break-even price would be. Okay, nice work. So breaking even means that you need to bring in as much money as what the expected value cost would be. A profit means you have to bring that much more in above the expected value, and so on. Okay, one thing I want to point out before we move on to another problem. Go ahead and add up all of these numbers in the probability column. So you have 0.65 plus 0.24 plus 0.07 plus 0.02 plus 0.01 plus 0.01. What do you get? 1, okay. So this column adds up to 1. In the previous problem that we had about the roulette, we had, well, no, even before we get to the expected value, just the probability column, we had 1 out of 38 and 37 out of 38. Okay, so the probability of landing on 20 was 1 out of 38, and the probability that you land on some other number was 37 out of 38. So what do you get when you add these two together? You get a 1. Okay, so something to keep in mind in your problems for expected value, that your column for probability should always add up to 1. Because remember that 1 means that absolutely something is going to happen. Well, yes, it's definitely one of these outcomes is going to happen, so they all have to add up to 1. So you're either going to win or you're going to lose. Absolutely, no doubt about it, okay? So all those probabilities have to add up to 1. An architect is considering bidding for the design of a new museum. The cost of drawing plans and submitting a model is $17,000. The probability of being awarded the bid is 0.1, and anticipated profits are $170,000, resulting in a possible gain of this amount minus the $17,000 cost for the plans and the model. What is the expected value in this situation? Okay, so in the last problem, the chart was already made for you, but pretty much most of your problems, the chart is not made. So we're going to go back to that chart that I showed you already. We need a chart of outcome. Okay, so outcomes, gain or loss, and the probability of that happening. Eventually, we'll have a column for products, but we'll get to it when we get there. So this is the main thing that you need to remember here to create your chart. All right, so an architect is bidding for this new museum. What are the possible things that could happen when he bids for the job for the museum? Okay, he could get the job or not get it. Okay, so, and they use the word awarded the bid, so I'm going to just use that same wording. So he's awarded the bid, or he's not awarded the bid. Okay, so if he is awarded the bid, what is his gain or loss? So it's going to be $170,000 minus the $17,000. Okay, so they even told you that right there, possible gain of. All right, so we have 170,000 minus 17,000. What does that equal to? 153,000. Okay, the probability of being awarded the bid is not, well, careful, I'm not quite sure how you said that, but be careful, it's 0.1. All right, so then what is the gain or loss if he's not awarded the bid, he or she? Okay, 17,000, is that a gain or a loss? It's a loss, so we need a minus, right? So minus 17,000, because it's going to cost him that much money just to put together the bid. Okay, so that would include, man hours, any materials that he might use, floor plans that he has to make. Maybe they make a model of what it would look like. Okay, all kinds of costs that might go into doing that. So if he doesn't get this job, he's out that amount of money, he or she. All right, so what's the probability of not being awarded the bid? 0.9 is correct. Good. They did not tell you this in the problem, but the pattern that we just learned was that this column had to add up to 1. Okay, so in order for this column to add up to 1, this must be a 0.9, so that 0.1 and 0.9 add up to 1. Now, you don't have to guess. You could always just do 1 minus the 0.1. And that'll give you the answer, okay? So 1 minus the 0.1 will give you the 0.9. All right, so we've filled in all the information we need for the chart, and so now we need our column for products. So we are going to multiply our gain or loss with its probability. And so 153,000 times 0.1. Okay, 15,300. Negative 17,000 times 0.9. Minus 15,300. 1530. Did everybody get that? Okay, I'm going to check it because we've got disagreements here. So 17,000 times 0.9 is 15,300. So negative 15,300. Okay, make sure you had the right amount of zeros, and make sure it's 0.9 when you're typing it in. All right, so now when we add these two numbers together, what do we get? Okay, so but the value is 0. That's our expected value right there, $0. Okay, so we're going to type in a 0. Well done. And now it wants you to choose the correct statement for what this means. Okay, so you have choice A, B, C, D. We'll do choice 1, 2, 3, and 4, and I'll read them out to you if it's a little small. So choice 1, in the long run, the architect would expect to break even. Choice 2, in the long run, the architect would expect to earn this amount. Choice 3, in the long run, the architect would expect to lose this amount. And choice 4, none of the above. Okay, so 1, 2, 3, or 4. And I see a majority with 1. And the majority is correct. Fantastic. Okay, so if you get an expected value of 0 when you're talking about money that you're either going to earn or lose, then yes, that is breaking even. So this means that if this architect continues to bid on these huge jobs, it's a huge job, okay, a museum. It's got a high risk, okay, there's not a lot of museums being built these days, right? So the probability that he get the job, there are a lot of architects, not a lot of museums, is just 0.1. But at least he would break even on this job. So he would earn what his costs would be. And this is not just on one job. This is if you continue to do bid for jobs like this. Because what this means is that, you might not get the bid for this museum, but then later there'll be another big project similar to a museum that you bid on that's got the same, same intent on that job. Maybe you get that one. Then maybe the next couple ones that you bid on, you don't get. So you earn some money, you lose some money, you earn some money, and so on. So over the long run, you're going to get an expected value of 0. This may or may not be a good move on the architect's part. Now, it all depends on what their focus is. So breaking even on this job, he can't live on breaking even. But there are other ways that he can compensate for that. He could also do other types of jobs for his firm and make money on the other types of jobs. This might be a good PR job. Okay, maybe you break even, but your name gets out there and you don't have to pay money on the publicity and advertising that you would need. Okay, so there are certain reasons why you would want to break even, and that's okay. And in other types, now maybe he's a nonprofit architect. I don't know too many of those, okay? But in a nonprofit, if in a nonprofit job, you are trying to break even. Okay, that's the whole purpose of that nonprofit organization, is that they need to spend the funds that are coming in, and so on. Okay, so let's take a look at one more. Okay, a store specializing in mountain bikes is to open in one of two malls. If the first mall is selected, the store anticipates a yearly profit of $75,000 if successful, and a yearly loss of $25,000 otherwise. The probability of success in this particular mall is 1/2. If the second mall is selected, it is estimated that the yearly profit will be $50,000 if successful. Otherwise, the annual loss will be $15,000. The probability of success in the second mall is 3/4. Okay, so you're opening a store. You have 2 different locations to do this in. You have hired a research team to find out this information. They have studied lots of different businesses in these areas, and this is what they've determined based on what they have, that information that they have. Okay, so it says, what is the expected profit for the first mall? So notice that it's shown you, oh, you're going to do an expected profit for the first mall, and then you're going to do an expected profit for the second mall. So we actually have to do 2 charts for this problem. All right, so for the first one, again, we have outcome, gain or loss, probability. Okay, so you go to the first mall, you open a store in the first mall, and what's the possible thing that could happen? Think about the words that they used in the problem. Successful, right, was the word that they used in there. So you could be successful or unsuccessful or not successful, however you put that. Okay, so if you are successful in the first mall, then what is your gain or loss? Okay, 75,000, they told you that right here. So, and is that a gain or a loss? A gain, so it's a positive number. So profit of $75,000 is successful. Okay, and if you're unsuccessful? Okay, so it's right here, that 25,000, but since it's a loss, you need negative 25,000. Okay, what is the probability that they gave you? 1/2. Probability of what? Success. Okay, so if you're successful, or the probability of being successful is 1/2. So I need to put that in the row for successful. So what would be the probability of being unsuccessful? That's the success of the other mall, the 3/4. But I did hear somebody say it. It was 1/2, right? Because remember that this column has to add up to 1. Okay, so there's our first chart. Let's go ahead and multiply. So 75,000 times 1/2. Okay, let me use a different color here. So 37,500. So I didn't make my column. This is my products. Okay, what is negative 25,000 times 1/2? Negative 12,500. Okay, add these two numbers together. So 37,500 and a negative 12,500. Okay, so I heard 15,000. I heard wrong. 25,000. Okay, good. Okay, so 25,000 is our expected value for the first small. Okay, these were yearly profits and losses. So this means that, you know, the expected profit for this first small would be 25,000 a year. Okay, so everybody got that? So typing in $25,000. Fantastic. Math Excel is very happy with you today. Okay, what is the expected profit for the second mall? So now I want to give you guys an opportunity for a couple minutes to see if you can do this chart from scratch. Okay, I'll write out the information a little bit bigger in case it's hard to read. But the second mall says that its an estimated yearly profit will be $50,000. And then loss of 15,000. And the probability of success is 3/4. Okay, let's see how you did. So we've got outcomes, gain-loss, probabilities. Okay, what are the outcomes of this one? Successful, unsuccessful. So nothing's changed here. Okay, and so the gain or loss if you're successful. Okay, positive 50,000. And if unsuccessful, negative 15,000. The probability of success at this mall? 3/4. And so therefore the probability of being unsuccessful? 1/4. Good, because this has to add up to 1. So now multiplying across, okay, so what was the first one? 37.5. And then 15,000 times 1/4? Negative. Okay, negative 37. No, that doesn't make sense. Okay, so I didn't hear right. So, oh, okay, so, so 3,750? Okay, so, but I heard some people got different numbers. Everybody okay? I just want to make sure everybody's on the same page. Okay, so maybe make sure you put in 3 zeros. So, okay, so yeah. So again, a lot of it is just double checking to make sure you type those numbers in correctly. So now when you add these numbers together, 33,750. Okay, so this time your expected profit is 33,750. Okay, so 33,750, there's still one part remaining here. Well done. Okay, so choice 1, the first mall should be chosen in order to maximize profit. Choice 2, the second mall should be chosen in order to maximize profit. Choice 3, either of these two malls may be chosen, the profit is the same. Okay, so 1, 2, or 3? Hopefully it's a little obvious at this point. Okay, so 2, fantastic. Okay, now notice though why it might be important to work this out. If you look at the original information, you were told that, you know, if you're successful at the first mall, you could get $75,000 in annual profit. And so that could be really enticing, okay, because that's more than the $50,000 that you're expected a year at the other one. But what's going to happen is one year you're going to be successful, the next year you're not. Okay, you know how the economy is. Okay, you guys know how the economy fluctuates, okay? A few years back, the housing market was great, okay? Then not so much, and so on. So that's why it's important to look at what's expected over the long run and not necessarily look at what's happening right now, because that's what these numbers are, is what's happening right now. So, so again, you could be really enticing, but when you look at the numbers, oh, okay, so it looks like I'm going to do better at that second mall if I go that way. So this is you know, an occupation that somebody does. You know, they help businesses figure out what would be the best expected value and so on, so that you can make better decisions for your company. Is it always going to end up this way? No, because that's the nature of probability. You're still taking a risk, because even though the probability may be high, something else can happen. So, all right, so for homework so far, 11.8,